All right, here we're looking at section 5 in our algebra review. So our learning targets for today, first we're going to reduce a rational expression to the lowest terms. And all of these we're going to be dealing with rational expressions. Then we're going to multiply and divide, then add and subtract, and then we're going to be able to find the least common multiple, which will make it a lot easier down the road. And then we're going to simplify some complex rational expressions. So just remember, a reminder that a rational expression is where I have a polynomial divided by another polynomial. This would be a rational expression. So this is what I'm going to be working with. So our first thing we're going to be doing is reducing and kind of simplifying. So I know if I'm multiplying in my numerator and multiplying, and I have the same thing in both numerator and denominator, I can simplify and cancel those out. But only if I'm multiplying, never if there's addition or subtraction in either the numerator or the denominator. Okay. So here's our couple of examples. We're going to reduce each rational expression to the lowest term. And generally when we're working with rational expressions, our first step is going to always be to factor them, which we'll see here in these next couple of examples. So here's my solution, right? So I started with x squared plus 4x plus 4 in the numerator. So first I factor that, and I can factor using any of the ways I know how to factor. So that becomes x plus 2 times x plus 2. I also have to factor my denominator, x squared plus 3x plus 2. I can factor into x plus 2 and x plus 1. If you need some reminders on factoring, please come and see me and we'll just talk through that. So now that I have it completely factored, now that I'm just multiplying two things in the numerator and denominator, any of the commonalities I can get rid of. So here I can get rid of that x plus 2 in both the numerator and the denominator. I do have to make special note though that x cannot equal a negative 2 or a negative 1, because that would in fact make the denominator 0, which we can't have happen. So we're always going to be having some excluded values with these rational expressions. So now let's look at our second example. Again, my first step is to always factor and then simplify. So I see this top one is a difference of cubes. So I can look back at my difference of cubes to factor this one. In my denominator, I see that each term has an x squared. So let's go ahead and factor that out. So now that I've completely factored out the numerator and denominator, I can get rid of any commonalities and then simplify. And again, I include my excluded values. Then our third example, right? Same thing, I factor out. Well, I notice each term has a 2, so I can get rid of that, and then I can factor out my denominator. Well, they're not quite all the same, but what if I factor out a negative 1 from the numerator as well? That'll get me to get this x minus 4 to go away. So I can factor out that negative 1 from what's left in my parentheses in the numerator. So I end up with a negative 2 over x plus 3. And again, my excluded values that make my denominator 0. So that's just how I can simplify things. But we're going to follow a lot of these same steps when we do other operations as well. So here we're going to multiply and divide. And we start by multiplying and dividing because it's more simple, right? When I multiply fractions, I multiply straight across the numerator and then straight across the denominator. When I divide fractions, I don't actually divide by fractions. I take the numerator and I leave it alone, and then I take the denominator and multiply it by the reciprocal. So I flip it upside down. So then I can end up with what I'm really looking for. And I end up multiplying, which makes things a little bit easier. Okay, so here's our examples. So first step is we're going to be multiplying or dividing. Okay, so, and then we're going to simplify. And we can always leave our answer here in factored form. We don't have to then multiply it out again. So let's look at what we're going to do here. So the first thing we go ahead and do, again, is to factor. We want to factor everything first so we can simplify as much as possible before we actually get going. Okay, so you'll see over here I've factored both of my rational expressions here. So I factored my first one and I factored the numerator and the denominator in both of them. So now I can go ahead and get rid of things that are common. Okay, so let's not look at that yet and let's see what we see. So I see I have an x minus 1 and an x minus 1, so that gets rid of one of these x minus 1s. Okay, I also see I have an x squared plus 1 and an x squared plus 1, so that goes away as well. So now I can go ahead and multiply what I have left, so just straight across the numerator and straight across the denominator to get my final answer. So the things that I have left in the numerator were this 4 and one of my x minus 1's, so that becomes my numerator. And then the denominator had this x left and this x plus 2, so that becomes my denominator. Nothing else can cancel, and again I have to include all of the values that at one point would make my denominator 0. So let's look at that second example where we were dividing. So again, we're dividing, but instead of dividing, we don't like to divide fractions, so I leave the numerator alone and I multiply that by the reciprocal, so upside down of the denominator. Well, now I'm just doing a problem like I just did, multiplying. So my first step is to factor both, and then I can go ahead and get rid of things that are common. So I see an x plus 3 and an x plus 3. I see an x minus 2 and an x minus 2. So now that I've completely gotten rid of the things I can go ahead and multiply out and see what my final answer is. So see there, we cross things out. We go ahead and multiply. We leave this in factored form. We don't have to actually multiply these pieces out. And again, any piece that will make my denominator 0 still has to be included because these are not possible values. So now we're going to add and subtract some rational expressions. So the difference when we add and subtract is, remember, when we're adding or subtracting fractions, the denominators must be the same. When you multiply or divide, they do not, but here we have to make our common denominators. And that's exactly what this shows, is that I have to have a common denominator. So let's look at some examples. So this one I see I have a common denominator. So I've got 2x plus 5 and 2x plus 5. So now I know that I can just add my numerators together and kind of simplify from there. So when I'm adding, I can just simplify. And then once these pieces have been added, I want to factor my numerator to see if there's anything I can cancel. And in this case, there's not, so this will be my final answer. So now what do we do when I don't have common denominators? I first have to create a common denominator. So here I see I'm subtracting, but I do not have common denominators. So the first step is I have to create those common denominators in order to add or subtract. So I want to go ahead and use my common denominator of all of it together. So my common denominator is going to be x times x squared minus 4. So now I have to find the new numerators to get me there. So I take this entire first rational expression and multiply it by x over x, which is the missing part from the denominator. And I take the entire second rational expression and multiply it by x squared minus 4 over x squared minus 4, right? The missing piece of its denominator. So once I do that, I have my common denominator, which is this x squared minus 4 times x, and then everything together in my numerator. Okay? So now I can go ahead and simplify. So I know x squared times x is x cubed minus, and this is just times 1, so x squared minus 4. But I'm distributing this negative sign. Don't forget to distribute. This negative sign goes everywhere, right? So now I have x cubed minus x squared plus 4 plus my denominator, and I went ahead and I factored out my denominator. Okay, so now this is as far as I can go because I can't really factor out this numerator, so I know I'm done. So there's another way I can find a common denominator. I don't always have to multiply them together. I can find the least common multiple. So let's not look at this. We're going to actually walk through an example that will help us the best. Okay? So first we're asked to find the least common multiple of these polynomials. Okay? So I have x times the quantity x minus 1 squared times x plus 1, and then I have 4 times x minus 1 times the quantity x plus 1 cubed. So let's see how we can find the least common multiple. Okay? And this walks us through our steps pretty nicely. So first, we factor. These are already completely factored, so we're done there. We don't have to do anything else. So step 2, I'm going to start with my left-hand one. Okay? Doesn't matter, but we just start generally with the left. So write down all of the factors of that left one. So now I'm going to add in any factors of the right one that I don't already have here. Okay? So I see that 4. I don't have a 4 already here, so we insert this. So it's going to be a 4x. Okay? So now I look at my next factor, this x minus 1. Well, I already have an x minus 1, so I don't have to change anything. Okay? So our third one, this x plus 1, I only have 1 here. that I started with. But this tells me that I've got 3. So I have to add in 2 more to get everything that I'm missing. So I just changed that to a 3. So my final is, right, this 4x times x minus 1 squared times x plus 1 cubed. So I always factor everything first, then start with 1 and list everything, and then add in anything that we didn't already include. Okay, so now we're going to add these rational expressions, but we're going to first find the least common multiple. So the first step I want to do is I want to factor everything. Okay, so I factor all of my pieces, and this is all of my denominators. So now I can see what I have common and what I'm missing. So my least common multiple is x plus 2 times x plus 1 times x minus 1, because that includes all of the different pieces. So then I'm going to write each rational expression using my LCM, so this piece here, as my denominator. This becomes my new denominator. So now once I do that, I have to multiply the numerators by the missing pieces. Okay? So if you see over here, right, I just have this x, and the piece that was missing from this denominator was that x minus 1. So I can multiply that numerator, that x, times that x minus 1. So now let's look at the second piece, which might be on the next page. It is. Okay. So now that second rational expression, right? So I had that 2x minus 3 in the numerator. The piece that was missing from this denominator that's included in my LCM was this x plus 2. So I multiplied numerator and denominator by that x plus 2. So now I have my common denominators. So now I can just add my numerators, right? My denominator stays the same and my numerators get added together. Once I do that, I want to go ahead and simplify as much as possible, right? We're going to leave the bottom, the denominator, completely factored. But now I can go ahead and just add my like terms and simplify here. Well, I see that I can factor a little bit more because each of these terms can be divided by 3. So I go ahead and do that to get my final expression and my final answer. Okay. So now we're going to be looking at some simplifying some complex rational expressions. All that really means is that I have some fractions within fractions. Okay. So here's our first example. And there are 2 different ways that we can do this. And it doesn't matter which way you do. That's what this last was telling me. So I follow option 1. I like to break things down into small chunks and then do the little pieces. This option 2 kind of looks at everything as a whole, but either way will work. Okay, so here's our complex rational expression. So we have to simplify it. Okay, so the first thing we want to do is figure out just the numerator, right? Because I see I'm doing something in the numerator. So let's deal with that first. Okay, so I want to go ahead and simplify that. So I know I've got 1/2 plus 3 over x. Well, I know my common denominator is going to be 2 times x. To get this numerator, I have to multiply times x. To get this, I have to multiply by 2. So I end up with x plus 6 over 2x. And then I can simplify a little bit more, right? So there we go. So now let's look at the denominator. The denominator only had one real thing going on. I don't have to combine anything, so I can leave it alone. So now that I've simplified the numerator, I go ahead and divide my fractions, but I don't like dividing fractions, so I go ahead and multiply by the reciprocal. Well, now I'm just multiplying, and when multiplying, I can just multiply straight across. Okay, so I can also simplify before I multiply, but here we've multiplied, and now I want to cancel out anything that I can get rid of. So I know that 2 goes into 4 2 times, so that's what I'm left with, and there's my final answer. Okay, you can also look at option 2. I think it's much more difficult to look at everything all at once. So if you want to walk through this one, please do, but I'm not going to walk you through it. Okay, so here's another example, a little bit more complicated. So here you see in the numerator and in the denominator, we're doing some operation, so we have to simplify that first. Okay, so we're going to look just at the numerator. Okay, so first thing is you want to add these fractions, but I don't have a common denominator, so I have to find my common denominator, which we're going to use as x minus 4. In order to get this second term to have that same denominator, I multiply by x minus 4 over x minus 4. Now that I have common denominators, I can go ahead and add and simplify. So now we're going to do the same thing with the denominator. Again, I see I'm adding or subtracting, so I have to come up with my common denominator, which is x. Once I have both terms to have a common denominator, I can add or subtract and then simplify. So now once I've done that, I go ahead and I factor everything, all of my different pieces, right? So this numerator can be factored. But then again, here I'm dividing a fraction by a fraction, and I don't like dividing fractions, so I leave the numerator alone. I find the reciprocal, so I flip the denominator upside down, and then I can multiply. But before I multiply, I'm going to go ahead and cancel out anything that can be. So I see I have an x minus 2 and an x minus 2. So I get rid of that before I multiply, and then I can just multiply straight across. And I can leave everything in factored form. I don't have to go any further than that. Okay, so now let's look back at our learning targets, dealing with our rational expressions. So first we reduced a rational expression. Then we looked at multiplying, dividing, adding, and subtracting. Just remember, when I add or subtract, I have to have that common denominator. Then I found the least common multiple, which is an easier way to find that common denominator when we add or subtract. And then we looked at some complex rational expressions where there were fractions within fractions. So now that we've walked through some of this, go ahead and work on that homework.